Okay, this is video 3 on how to use Excel for statistical analysis. So the first two videos really showed you how to manipulate data as well as how to do pivot tables, which are really helpful for frequencies and things of that nature. Now, when we get to doing statistical inferential tests, what helps us is the free add-in in Excel called the Data Analysis Toolpack. In order to get Data Analysis Toolpack, you would have to. So it appears here in the data section. There's one on the far right corner called Data Analysis. If you don't have it, which is very likely that you don't have it, what you can do is you go to File and you go to Options. When you go to Options, you see here that there are different options, and we want to go to Add-ins. When we go to Add-ins, then there's going to be this Analysis Toolpack and Analysis Toolpack VBA. VBA is stands for macros. You can install them both. So install Data Analysis Toolpack. It will take like a minute or two. It's not a big one. And yeah, and you just use it. Then after that, after you install, you probably have to restart Microsoft Excel. And when you go to Data, you will see the Data Analysis Toolpack. So this Data Analysis Toolpack, if I click on it, I could see what sort of analyses it can do. It can do ANOVAs, it can do correlations, covariance tests. It can do descriptive statistics, and it can do, histograms and t-tests, so student t-tests, regressions, and it's for a lot of studies that this is where you start, right? And if you do correlational analysis, if you do regression. So let's start with descriptives. So remember, I showed you here on how you can get descriptive statistics for. So this is our pivot tables. So remember, I showed you how to do pivot tables. How can I do descriptive statistics with average, minimum, maximum, for instance, using pivot tables? A faster way to do this would be to use this Data Analysis Toolpack. So you can get descriptives, right? You can get descriptives for variables, interval ratio variables, for instance. Here that's income, right? Income jumps at us right away. So if we want to do descriptive statistics, we can just select descriptive statistics, then it asks for the input range. So when you do, when you include the input range, include it together with the column heading, right? With your variable, name of the variable. And I hit Control-Shift down to highlight this whole column, which is our whole variable that we're interested in. And it's basically, I just have to say that label's in the first row, and I have to check it so that that Excel knows that income is the name of the variable. And yeah, so what we do is we hit, and where do you want the result? Do you want the result in a new worksheet? Well, let's do the new worksheet. Instead of output range, you can just highlight area in your on your Excel. It's just easier for us to do a new. So I hit OK here. Please choose at least one statistical option. Okay, so yeah, we want summary statistics and the confidence interval as well. And I hit OK. And here's what we have here. And let me format and adjust column auto-fit column width. So this is the type of statistics that we get. We get the mean. This is, I guess, income. Yeah, the mean income, and as you remember, it was the same mean income, 69.47. Same here, right? So it's our results of our descriptive statistics fast, just much faster than pivot tables, right? When we get to like descriptives, there's median 45 because yeah, in if you do income or salary, it's much more precise if you use median instead of mean. And you see it just talks about the skewness of the data, skewness of the income, and so it's negatively skewed because our average, our mean, is actually higher than our median, and that means, you know, a small number of people make a lot of money, basically. We see the standard deviation, and then we see the skewness and kurtosis. See the skewness is pretty high, and minimum maximum. So minimum income is 9, maximum income is many times higher. It's probably because these are outliers. So you can remove them, you know, when you do the data cleaning. Okay, and you know, sum of income count and confidence interval, confidence level. Okay, so this is our descriptives. It helps to, you know, to rename your worksheets, because otherwise you sometimes lose track. Okay, so this is how you get you know, how you use descriptive statistics. Now let's move to inferential, to another descriptive statistic, correlations. So with this tool, data analysis toolpack, it requires you to select areas, right? So if you select, for instance, if you select like this area, yeah, right, or like these variables, it will include these variables in the analysis. So if we do correlations, we do it with the interval ratio variables, right? So let's see if we do correlations for yeah, and let's make another just recode it. We didn't touch original, remember, so I'm just gonna create a copy and say stats analysis or something like this. So, for instance, we want to do our analysis of we want to do correlations, right? So let's see if we so this is employee is the number of years that the person was employed. Let me just insert several variables here. So it's you know, it's a lot of copying and pasting, of course, but it works. It's pretty easy to do. So say income is our, and we have age here, don't we? Let's see. So yeah, we have age variable, we have income. So let's see, we're interested in how income is associated with age, and associated with employee means number of years a person was employed. And what else do we have here? Reside. I don't know what reside means. It's probably where the person resides. Well, let's for the sake of this demonstration just take these three variables: income, age, and employment, and how many years were employed. So we want to see how these three are correlated. Very easy to do with the data analysis toolpack. You go to data, data analysis, you check correlation. So for correlation, it requires your input range, right? So by input range, it means like you have to select all the variables. That's why I put them all next to each other, because it's just easier to, you know, to highlight them all. So I included them all, and Control Shift and down, which basically selects all the observations. So income, age, and employment, and the years of employment, right? So I selected the three of them in order to see how they are correlated here. I hit labels in the first row, so so that Excel understands that these are labels, and I can identify the output range here. But let's do it in a new workbook, and here you go. This is our correlation. and you see that income is correlated with income at 1, and it's just a typical representation of a correlation, but we see that age and income are correlated at 0.335, and employment and income, so if you the more years you work, the higher your income tends to be, and the more years you work, the higher your age is, or the vice versa, I guess. Remember, those are association, not making any causal claims here. Okay, if you want to go further, and you see that, well, these variables seem to be correlated very, very well. How about we run the regression now? So let's go to our stats analysis. Again, we have these 3 variables here sitting next to each other, and I hit data analysis, and I'm interested in doing regression now. So let's do regression, and we identify that our outcome variable is income, right? So we want to predict income based on the years of work and on the age of the participant. So here I identified the income as an outcome variable, and our predictors are age and employment. I also have to make sure that it's labeled, because I selected the whole the whole range here, and let's get the results. So you can do residuals, you can do standardized residuals. It's just gonna be pretty long. It's gonna be a pretty long output. So let's confidence level 95, and we just hit OK. It thinks a little bit, and then it creates this creates this output and the several residual plots and several charts here. Anyway, what we're interested in here, statistically speaking, is the multiple R, so multiple regression coefficients. R squared is the extent to which the variables that are the predictor variables account for the variation in our outcome variable. So it's a pretty high here at 0.33. So 33.66% of the variability of income can be predicted by the 2 variables, by age and employment. And here we see that overall regression model is statistically significant. It has 0 here. Typically it uses scientific notation, just like here, minus da 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 da. If you want to get rid of scientific notation, you just press this, and it's pretty significant. So somewhere down 0.0000, somewhere there's 1 or another number, but it's pretty significant, right? So the model seems to be significant. It's a pretty good fit. The F value is super high, which is not, because it's a fake data set, it's probably not shown. So age and employment, here we have such helpful data as the p-values, right? T-statistics and coefficients, very important. So yeah, that's just to show you that you can do regressions here, and and there's a couple more tests that we can use, such as t-tests and ANOVA, which I'm going to cover in the next video.